This is the last video for mole concept, and it deals with limiting reagents. Limiting reagents are simply this. Every reaction has certain reactants A and B reacting together to produce products C and D. However, if there is a limiting reagent, means A is limited. When A is totally used up and you have lots of B left, the reaction stops. You cannot produce any more C and D because A is totally gone. So, an analogy will be something like this. If I were to form a human being, I have 3 heads and 1 body. Okay, in this case, what will be limiting me from producing more human beings or more robots? So my limitation in this case will be my leg, my body. My body will be limited, and my excess will be I have 2 more excess heads because this will go with this. They will form 1 human being. I will have excess of 2 heads. So this is the concept of limiting reagents. Which one will be used up? The limiting reagent will always determine the number of products formed, not the excess. So now we're going to use an example to explain about limiting reagent. This is the oxidation of magnesium to form magnesium oxide. So equation is balanced. Let's start. We are given 3 moles of magnesium and 5 moles of oxygen that has reacted. This is what is given in the question, 3 moles and 5 moles. Now think back about the human being and the head. Ratio is 1:1. So 1 magnesium will react with 1 oxygen, 1:1. So if you have 3 moles of magnesium, 3 moles will naturally react. Okay, so if 3 moles of oxygen has reacted, what will be the balance? The balance will be 2 moles of oxygen excess that has not reacted. So since this guy is the limiting factor, he will determine how much magnesium oxide is formed. So 3 moles will give you 2 moles. Using ratio, 6 moles will be formed. Now in this example, the ratio is 1:3:2. So ratio is 1:3. And let's have a case study. Let's have given 5 moles of nitrogen is reacted with 5 moles of hydrogen. Now this is given, 5 moles is 5 moles. So this is the actual moles that is given during the reaction. So these are both given. So if I use 5 moles of nitrogen, I would require 15 moles of hydrogen, but I do not have 15 moles of hydrogen. I only have 5 moles to start with. So in this case, nitrogen is not the limiting factor. I'm limited by hydrogen. So let's try the other way around. So if I use 5 moles of hydrogen, how many moles of nitrogen will I get? So if I look at it correctly, 3:1, this will be 1/3. So if I use 5 moles, it will be 5/3. Now the 5 here is not this far. 5 here will be from here, 5/3. Okay, and my excess nitrogen will be 5 moles here minus 5/3 because I only will require 5/3, and that will be 3 and 1/3 mole of excess nitrogen that is not reacted. And since this is the limiting reagent, 5 moles of hydrogen, which is completely used up, will give me 5/3 times 2. 3:2. So I divide 1 unit first, then times 2. And this will give me 10/3 moles of ammonia gas produced. Okay, for the last example, if you have 5 moles and 1.5 moles, these are actual things that's given. So think carefully. From here you can spot which is the excess. If I use 5 moles, I will definitely require 10 here. So I'm limited again by oxygen. So oxygen is the limiting factor. So with that, I'm going to start. If I'm using 5 moles of oxygen here, that will require 1.5 moles here. How much of methane will be required? The actual volume that is required will be 1.5 divided by 2. 2:1. Okay, but do I have enough? I definitely have more than enough. I have 5 moles here. So my excess that is unreacted will be 5 minus what I have used up, and I have 4.25 moles of methane. Now if the questions ask you to find the mole of carbon dioxide, just use the limiting reagent, and 2:1, 1.5 divided by 2 moles will give you the moles of carbon dioxide form. These questions can be further expanded by asking you about the volume of carbon dioxide form from the limiting reagent, and all you need to do is times 24. If you are asked to find the mass of CO2 times the molecular mass, the MR, 44 grams, and you will find the mass of carbon dioxide.